All right, students. So after knowing what's the difference between an expression and an equation, all right, now it's time to do some examples, right? So if you look at what we have on the screen, we are asked to factorize this polynomial. And let's put what we have learned in practice. So you can only factorize an expression. So therefore, what you're given is an expression. Okay, now, so this is a cubic polynomial. And for cubic polynomial, we can't use your cross method or the box method to factorize it. We will have to use the factor theorem. Why do we use the factor theorem? Because the factor theorem will allow us to find the one divisor. Okay, allow us to find the divisor, which is a factor, and that will give us remainder equals to 0. So basically, what we need to do is to find a factor. So if a divisor is a factor, then the remainder is 0, and that is factor theorem. So we can actually write, okay, we just name our polynomial as f of x, and this can be written as ax plus b multiplied with a quotient, and our remainder is 0 because that's factor theorem. So I'm just going to forget about writing plus 0. All right, so one tedious method is to use trial and error. Okay, that means what we are doing is we let ax plus b equals to 0. So ax is negative b, x negative b over a. So basically what we're trying to do is we have to use trial and error to find a suitable values of x, substitute into your fx, and hopefully you get remainder equals to 0. So you can use factors of -6 or factors of 2. So you can try letting x equals to, let's say, factors of 2, and then let's sub inside and see what happens. And you use a calculator. Yeah, and you have remainder equals to 0. Right, so if you substitute x equals to 2 and get remainder equals to 0, right, so if you were to convert it backwards, it means that your x minus 2, okay, what do you mean by convert it backwards? All right, converting it backwards means, okay, you start from here, okay, you manage to get x equals to 2, right, and then you go back to one more step, go backwards one more step, right. Yeah, 2 is an integer, so you don't really have to, if it's a fraction, then you have to multiply by a to convert it back to ax equals to negative b. Then you go one more step, right, so you will have x minus 2 equals to 0, right, and if you go one more step, then x minus 2 is your factor, is your divisor here. Okay, it's your divisor here. So because the remainder is 0, so x minus 2 is a factor. Okay, so this is one way of finding a factor, right? But sometimes it could be quite time consuming. So an easier way is to use the calculator, right? So using the calculator, how does it works if you use the calculator? So it depends on your brand of the calculator you're using. It could be Sharp or Casio. If you're using Casio, then it's on the calculator, you can just press mode 3 followed by 4. Right, and you have to remember to arrange your polynomial with the highest in descending order of the power. That means from the highest power to the lowest power. Okay, in this case here, it's the highest is 3, and then of course 6 can be written as 6 times x to the power 0. Right, and then you just key in the coefficient. Right, if you've forgotten what coefficient means, this is the coefficient, this one. So the coefficient of x cubed is 2, coefficient of x squared is 3, coefficient of x is negative 11, coefficient of x to the power 0 is negative 6. So you just key in all this number. Alright, so on your calculator, you will see x1 equals to negative 3, x2 equals to 2, and x3 equals to negative half. Alright, so if you were to convert it, okay, convert it back, you will have x plus 3, x minus 2, x plus half, which you have to write it as, wait, hang on, you cannot write it as x plus half. You have to write it as 2x plus 1. Okay, I'll leave you to think why is it we have to write it as 2x plus 1. So these are all the 3 linear factors that you can find using your calculator. Right, and to give you an idea how the curve will look like, okay, there's one intersection point there. There's another one here, and there's one here. And it will intersect at the y-axis at negative 6. Again, I'm going to leave it to you to find out why. Why is it that it intersects at x equals to negative 6? So basically, the curve will look in this manner. Right. So you must remember that the calculator is only a mean for you to find one factor, one O and E. So I'm going to erase all this now because I need the space. So if you can't exactly remember what I've said, please just go back to the slides again. Alright, so what I'm saying that if you're asked to factorize off at x and you just give your answer as this, okay, now remember you won't be getting all the marks. Alright, because the calculator is just a mean for you to find one factor. These questions also test you on other concepts involved, such as using the long division, such as using compare coefficients of similar terms. Alright, so you cannot just give your answer as these 3 factors and hoping to get full marks for it. So if that's the case, then how do you use the calculator? How do you use the value you obtain the calculator to help you? Okay, right. So now we have 3 factors here that you can choose. Alright, we would choose either the first one or the second one, or you can choose one of them, just choose one of them. So in this case here, I'm going to use x plus 3. Okay, and that you have to multiply with the quotient, right? So I'm going to use long division. The next slide, I will show you how to use compare coefficient of the similar term. Or maybe I can show it. I can just try to separate the screen into 2 halves. Okay, so this is using long division, and then you can do a comparison. Right, I'm not going to go into details how we do the long division. Right, you can refer to the earliest video. Okay, right, so that's long division. And then how do you present your answer? So what you get will be, right here, this will be equals to x plus 3 multiply with the quotient, which is 2x squared minus 3x minus 2. And of course, this one here, okay, if you use your calculator again, you will get all the factors are actually on the right hand side. This guy and this guy. Okay, so this is how you factorize your fx completely. Alright, so that is using long division. So if you're very good with long divisions, then you can use this method. Now the second method we're going to use is to compare coefficient of similar terms on both sides. And we'll do it at the next slide. Alright, so now we know the difference between an expression and an equation. Let's try to put what we have learned into practice. So if you look at example 1, you are asked to factorize 2x cubed plus 3x squared minus 11x minus 6. Now, so the key word here is factorize. Okay, and then if you look at the polynomial you're given, so definitely this is an expression. Okay, right. So for a cubic polynomial, to factorize a cubic polynomial, you can't use the box method or the cross method as like what you've done to factorize a quadratic polynomial, right? So we would have to use the concepts of factor theorem, and we have already managed to find one factor in the previous slide, that is x plus 3. There are two ways of doing it. You can either use the long division, which is pretty straightforward, which I'm going to show it to you here. Okay, using long division is quite straightforward. Okay, you take, I don't have to repeat that, you should know by now. Take the first term of your dividend, divide by the first term of your divisor. That will give you 2x squared, and then take 2x squared multiply again, which each individual terms of your divisor. Okay, and then the process repeats. Negative 3x squared divided by x will give you negative 3x. So negative 3x again multiply with your divisor. Negative 2x divided by x will give you negative 2. Negative 2 multiply again with the divisor. Yes, and you get remainder 0. You must get remainder 0. If you do not get remainder 0, means you have made some mistakes along the way. Right, so hence we can write this as x plus 3, and our quotient, this will be our quotient, which is 2x squared minus 3x minus 2. Now the keywords is to factorize it completely. So as much as possible, okay, you have to try to break it down into linear factors. Of course, there are some cases where you can't actually factorize the quotient anymore. Right? If this cubic curve has only one real root, then of course there's only one linear factor. However, this one you can break it down further. into 2x plus 1 and x minus 2. Alright, so this is pretty straightforward using long division. Right, another method is if you're not too comfortable using long division, then another method that I'm going to show it here. This method is called compare coefficients of similar terms. So this one is called compare coefficient of similar term. Alright, okay, so you have f of x equals to x plus 3 multiplied with the quotient. Okay, right, so your f of x is actually your f of x is of degree 3. So this one is degree 3. And the divisor is of degree 1. So therefore your quotient must be of degree 2 because 1 plus 2, because 1 plus 2 then gives you 3, isn't it? So how does a polynomial in degree 2 looks like? It will be in this format: ax squared plus bx plus c, where a cannot be 0. Think about why is it a cannot be 0, and then a, b, c are all constants. Okay, so there are three unknowns here. Okay, so basically we have already learned how to find the first one in the earlier video. Also, we have learned how to find the last one. Okay, so the first one is just taking x times ax squared, and that gives you ax cubed. Okay, so this ax cubed will be equals to the first term in your dividend, which is your 2x cubed. And therefore your a is 2. Okay, and for the last term, we also learn how to find the last term, which is 3 times c, give you 3c, and that will give us the last term, negative 6. So c is negative 2. Right, so if we were to write the dividend again, this is how it looks like. Okay, now so what we need to find is this term here. Okay, so when you say coefficients of similar terms, all right, if you look at your f of x, you have an x cubed term, you have the x squared term, you have the x term, you also have the constant term. So you can choose which term you want to compare with. So you can choose to compare your x, you won't want to choose x cubed, sorry, because you already done it here. You won't want to choose a constant term because you already done it here. So you're only left with the x squared or the x term. Okay, both of, if you choose the x squared, the answer you get for b will be the same when you choose the x term. So I'm just going to show you, okay, I can actually show you both. Right, so if I want the x squared term, then I will need to take this times this, and this times this. The rest are not relevant. And that will give me here, sorry, wrong, circle wrongly. That will give me this term here. And if you divide by x squared throughout, you will get 6 plus b equals to 3. B is negative 3. So in the event that you decided that, oh no, I want to compare the x term instead, you want to compare the x term, yes, it can be done also. Then you would have to take this, all right, to give you negative 2x. And then this one here, okay, you follow the red color one, plus 3bx. And this will be compared with the x term, which is negative 11x. You divide by x throughout. Okay, you see that you will get the same answer. Alright, So after doing that, you can just put it back into your fx, and you can factorize it, okay, completely.